Today we're gonna use Recon Pro to make our lives easier, and so I'm gonna show you my workflow when it comes to finding bugs. I'm currently mostly working on the red side, which means that when I participate in a contest, I'm basically just looking to break stuff. But when we're doing engagements such as the centrifuge one, the badger one, and another one that we're doing, which is yet to be announced. But when we're thinking about the blue side, we're thinking about maintaining the code a lot more. And so that's something to keep in mind. This presentation is going to be a bit more on the red side. And so the best place to get started to fuzz as of today is called Create Chimera App. Ideated Chimera was built by Antonio Vigiano. Nicanor, our upcoming fuzzing engineer, helped build the template. And so by using this template, you get access to a setup that automatically connects Medusa, Echidna, and Foundry, and it makes it work together. For the sake of time, I already downloaded it. So all I did was just git clone it with the name Recon Demo, or you can also just click use this template. And then I just forge built so that it will compile. And the biggest consideration that you want to have when you think about your iteration speed is that you basically never want to run Echidna or Medusa unless you actually want to do a run. So this is the first consideration in your workflow, is that you basically will have a, let's call it a scaffolding phase. And then you're gonna have more of a research phase, or a, let's call it a property phase, where you will actually check the output of the fuzzer and you're going to investigate these broken properties, or you're gonna just investigate the coverage. And so this first part is basically useless if you think about it, in the sense that it's obviously it's necessary, but it actually doesn't give you any information about the system. It just gives you information about stuff that you need to set up before you get to the interesting phase. And so your goal as a fuzzing engineer will be to minimize this phase so that you get to meaningful feedback as soon as possible, because the two main aspects that you want to look into in the second part of the, or I guess in the research phase, is going to be tied to the coverage, and the other aspect is going to be tied to actually breaking properties. And so generally speaking, that's what we do in every engagement at Recon, is we start by trying to get to meaningful coverage. The fundamental idea there will be, maybe we can build a very basic demo contract. Let me see if we have any suggestion here in the chat. Seems like nobody wants a specific project, but perhaps we could have, you know, a second number, and then we could have even a third number, and perhaps we would have some sort of a logic where if the new number is different from 0, we set this, and then if the new number is modulo 3 is equal to 0, so it's divisible by 3, then perhaps we set this one as well, and then perhaps we could, I guess you can't do third number like that, you have to do second number, third number. I guess this one, if it's divisible by 5, you would set this one in this case. And so perhaps you could look for a scenario in which you want all of the numbers to be set in one go, or basically you want to look at ways in which the code base, or I guess you want to look for ways to increase the coverage of your code base so that the tests that you can do on the code base become meaningful. Whereas if you don't have any coverage, then you may have meaningful tests, but those tests are not gonna work. So that's a consideration. That's just a style that we take at Recon, is that if you think about the pros and cons, the idea will be that if you write the properties, that's great. There's nothing wrong with writing the properties, having a spec, having documentation, etc. The problem is some properties will influence the code that you write because they may require ghost variables, they may require scaffolding, they may require changes to the actual code, for example, inheriting the vault contract and having to change it. And so because of that, they basically are a quest of their own. And so the same goes for coverage. And so if you want to pick one of the choose, if you have great properties but you have no coverage, then you're never going to verify them. Whereas if you have coverage, anytime you add a property, then your coverage is going to be meaningful. And that's where something like Recon becomes useful, because if I can leak some of my workflow without getting too specific, what you can see is that I can have a set of runs on my own tester run for hours, even days, and then I can just clone the corpus from these, download it locally, and get the benefit of having that run. That's what we typically suggest when it comes to setting up campaigns. And so the idea here will be that if you are going to work on a project, you can have a scouting run, like a massive long run that you do once you're done with a feature, and then you can save that corpus and you can reuse it. And that's because you don't want to wait unless you have to, but at the same time you will always have to wait. And so since you have to wait anyway, you may as well solve the coverage first, and then once the coverage is solved and you know that your handlers are leading the system to meaningful states, then you can work on the properties, because now every property you add will be compared against a corpus that is interesting. And so the only problem you may find is if some of your properties alter the corpus, or they fundamentally require a big shift in your target contracts, which is possible, but at the same time, it just is what it is. So that's why you want to focus on coverage. And the best way to focus on coverage is to follow this idea. This is something that basically I teach to our fuzzing engineers, and is the idea that instead of running Medusa, let's just look at the clock here, timer. Let's just run a timer. And so I'm on a like $3,000 machine here, and I'm gonna just run this timer. And obviously it's biased because I started it early, but fundamentally I'm wasting 30 seconds, a minute, 2 minutes waiting for Medusa to run. And so is that good or is it bad? That's a difficult question to answer superficially, but it's very obvious to say that let's say I have this coverage of 4, I can go and interpret that, but fundamentally, whenever I set up a new function, I could simply go and use the Foundry side to actually verify if this works. And so that's kind of what I teach my fuzzing engineers right now, is that instead of doing what I'm showing you, where basically we took more than a minute just to figure out what's going on. So we're going to try and find the counter contract, and we see that we have 100% coverage in this case. And so obviously this is such a simple example that we actually have close to 0 issues. But fundamentally, I guess what I'm going to do is I'm going to make the example a bit more complex to really give you the point. But fundamentally, instead of wasting a minute and asking me, how do I cache the build or whatever, the proper question is, how do we shorten our feedback cycle? And the answer is that because of the template we use at Recon, where you have the critic to foundry, then you are simply not supposed to run Medusa nor Echidna at this stage. So going back to our map, we are at the scaffolding phase. We have no idea what's going to happen. In this case, we get the target functions for free. Basically, we have them here, and we probably would have something a bit simpler. But fundamentally, we have this, and so the next step for us will be to simply go in Foundry and do something like this, where we would have test critic increment, and then we will do test critic, what is it, set number, and by doing that and running forge test, our cycle, our iteration cycle goes so fast that I barely have the time to set the clock, and we will get to a feedback. And the feedback is that for some values, these functions do not revert. And this is such an important consideration because Medusa and Echidna by default will not throw on a revert. That's how a fuzzer works. They do not tell you when your function reverts because the paradigm of having to deal with every try catch, which you can do, but it's such a reverse paradigm that it will drag you down because now you're trying to think of the things that you don't want to happen and you're trying to clamp out all of those values, whereas the entire philosophy around fuzzing is that you try random stuff so that you have a bigger certainty that the thing you want can happen or that the thing you don't want to happen cannot happen. And so that's why it's such a fundamental shift in their paradigm. And so going back to the board, as we scaffold, we have to be mindful of how the revert equals skipped. And so this is where something that our engineer Simon, which is here, OXSI, but basically what Simon is working on is the idea of changing our builder to have the quote-unquote revert mode, or maybe we'll call it the assert false mode. And so your first level will always be to run your feedback on Foundry because you will never be able to be faster. No matter what I show you later, you will never be faster than Foundry. So don't try to skip Foundry. Instead, use Foundry, be smart about it, and then let's go to the next level of complexity, which will be the assert false. And so this will be something that we plan on having as part of the Recon builder. You basically toggle a button and all of your handlers will be built with something like this, where you will see the name of the function as the failure message, and then we will assert false so that when you run Medusa, you will automatically get that false assertion. And so this will be a step closer to the actual tool. So it is a good next step in terms of complexity and in terms of time. At the same time, this is helpful because it shows you that that handler that was working, in the lab, it was working on the Foundry, is also working when it's called by the fuzzer. And so I feel like given this demonstration and given the fact that we have public functions, this example is completely useless, as in it doesn't give us any information. So let me show you an example that actually does give us an increment in information, because something we could do here, for example, again, because we are tied to Foundry and Medusa, we could actually make the parameterize this fuzz test, and then this way we would actually be running a fuzz test against this test handler, and perhaps we could find a set of values that will trigger a failure. In this case, we can see that there's probably some, and so that can be a very interesting way for us to determine whether the actually the counter increment is failing and the set number is actually not failing. But this could be an interesting way for us to kind of escalate our checks. If I'm not mistaken, we would have to do fuzz runs and then we would just set, let's say, to 10,000 I think this is 100,000, but it should be fast enough. And so that will be an example of you making your life a bit more complex to give you a bit more certainty. And so now let's move closer to the fuzzer and let's start to look at deeper aspects of the fuzzer. So the next example will be, in this case, we have a try catch. And so the main reason why you have a try catch in the tester is so that you can check for the revert cases, because again, as we said, all of the revert cases are skipped. And so in the case of set number, which is a governance derived function, I guess, you would expect it to never revert. And so that's an example of explicitly asserting this test and wanting to actually have that test. And obviously there are levels to this. The next level will actually be to have a test for every type of error. It takes a long time to set those up, but that's another example. But something that you could do for the sake of coverage, especially on the logical level, will be to perhaps assert that the new number is above a certain threshold. So let's say it's above 118. And so this, and we could actually try it both on Foundry and on Medusa. I'm just going to show that it works on both. So this will be our canary for coverage. And so this will help you when you're stuck for two reasons. One reason will be that you are stuck because you can't get a specific line to reach coverage. And the other reason why you will be stuck is instead that you don't know whether the coverage is actually being reached. And so what do I mean with this? Let's go back to the actual coverage report. This is something that I talked about and I call it the logical coverage versus the line coverage. So the fact that your contract is all green, what does it mean? It simply means that given the corpus, which is the list of functions that the fuzzer called, you can basically go and check them here. This is what the fuzzer actually did. It's basically just a bunch of bytes and calls. But given that, this is what we get. We get green, which means that this line did not cause a revert for some of these calls. That's all it means. It means that in aggregate, the corpus was able to cover all of these lines. But that doesn't mean that we actually tried all logical combinations. And so I think this is basically fizz buzz, like divisible by 3 and divisible by 5. And so the fact that we can do a fizz or buzz, or that we can do a fizz buzz, and that we can also just do a normal set of the number, doesn't mean that we went through all of them in that combination. As in, the fact that this is green means that one of these numbers was non-zero and this was set. The fact that this is green means that one of these numbers was divisible by 3 and this was set. And then this just means that one number was divisible by 5. But it does not mean that all of these conditions were met with a single number, which we obviously know it's possible. I guess 15 will be one of the answers. And so we know that's possible. Maybe we even understand that that's plausible, because let's assume that set number was called by a randomly generated number, or by some other more advanced DeFi concept. And so we may not have the proof that that number was actually triggered. So the way in which you will verify that a number happened will basically be this, right? Basically, we will just set this value and we will be like, okay, I know what the number is. This is the number I need. I don't care about anything else. Just put an assertion there and give me that number when the fuzzer finds it. So that will be a way of doing this. And obviously this should be broken in a moment. As you can see, it takes a second or so for it to be broken, plus the overhead of being in Medusa, which is higher than the Foundry overhead. But now let's think about escalating this to the next level. And so one way in which you could do that would actually be to have some sort of a bool canary for 118. So basically you will declare it. Let's just call it, I think it's fine. Let's call it canary for 118. And basically you will just set this by changing this to a if the number is set, then we're going to set our canary. And then we would have a separate either property test, or in this case, I'll just call it check canary 118 public. And basically we'll just assert that canary for 118 was not set. And the reason why we do this is because by having this check as an assertion, we can run echidna in assertion mode and it can cover everything. This is something that as of today makes the most sense. But the reason why you will do this, going back to the coverage, is that if we have this set of lines which are all green, and then we know again that one of the numbers triggered this and this and this, and then we put this canary, and we know that, let's say, this number solved for all of them, although I guess this is not divisible, whatever. Let's say, I guess we just change this to 15 and it should be fine. But let's say we cover that case, then the issue with having an assertion here with t, new number equals, or rather is different from 15, which means that this will be broken once the number chosen by the fuzzer is 15. The problem with this is that in the 15 case, our story, which is the corpus, basically our sequence, will always record that broken assertion as a revert, because we are reverting that call. It is a reverting call. And so that's why when you have more than one assertion, let's say you had, divisible by 3, and then divisible by 5, and then you add divisible by 15, then what would happen here is that if a number is divisible by 3, then that will be the only assertion that will be triggered, whereas the others wouldn't be hit. Whereas if you had the number that, I guess, by definition, every number divisible by 15 should be divisible by 3. But so basically we will never hit this line simply because all of those numbers that are multiple of 15 by definition are multiples of 5 and 3. And as such, we wouldn't hit that specific one. I guess we can do a demo. But what we could do if we wanted to get those, I guess we need to just do 0 here. But what we would want to do for this set of scenarios, and you can see how this is getting completely out of hand, but what we will do is we will just order them in the other way, and I'm not gonna save, so that means that the compilation that is happening now is the previous order, and then we can recompile and run it with the other order. But fundamentally, that would allow us to, and I guess we get this, random insane number, but fundamentally we would actually, how do I put it? We would get more insight by reordering the assertions by the least likely and the more likely. Although what happens with this type of approach is that now you are making the canary basically breaking all of your story. And so a better approach that I would look for would instead be to start having a tracker here, which would be basically, was divisible by 3. And so by doing that, you basically avoid all of those revert cases, and you're letting the fuzzer do what it should do, which is explore the corpus, explore all the combinations. And so by doing that, you are removing those constraints, because the issue with those constraints is that you will have a trigger that tells you that the coverage did happen, but that could be at the price of some future coverage or some more deep test that you're going to be unable to do because you are basically making the fuzzer revert in those logical paths. So this is something that should help you a lot. And the fundamental reason why you will do this is because you don't want to spend too much time maintaining stuff that can be avoided. And so anytime you find yourself not knowing if it works, if a handler works, start by going on Foundry and iterate through that. Once you are convinced that that works, then you should introduce a few canaries here in the handler temporarily, literally only when you're here. And then once you are done with that, then you should instead use what I would call almost the diary-like or the event-like aspect. And something that I'm experimenting now will be having some sort of a known address, something like OXFF999, where you will basically send event to a contract that you will etch into that address, so that you could then have some sort of a set of assertions of ordering. So you can assert that a certain set of operations has happened, or that some operation happened with some specific value. So those are interesting ideas that can help you explore the stuff that you don't see here, because everything is green, but that doesn't mean that everything was covered. It simply means that the language we're using to express line coverage is no longer sufficient to express what I would call logical coverage. So that's a big important aspect, and that's also why coverage is so key to then enabling interesting properties. Whereas when it comes to writing properties, I think, and like we do an entire workshop with our customers where we guide them through all options and talk about them and show them examples. But the first idea that I'm gonna leave you with today for to get started is going to be the following. What are the states, or I guess what are the properties that should always hold? So that's the first question that you should ask yourself. Are there said properties? An example of that will be on a Uniswap pool, you could have, let's say you do an initial deposit. And so a property could be that those tokens that were initially deposited, they would have a K, and that K should never be reached again, in the sense that the K should always be greater and that value should never be hit. Or perhaps the economic value of the pool should never decrease. And so that will be good, interesting global properties. And those are most likely global properties are the best bang for your buck, as in they tend to be easily identifiable at the beginning. They tend to be easily specifiable. An example in our counter could be that you can never have a negative number, which is banal and obvious today because we have uint, but it could be interesting once you start optimizing the counter to pack it, to have possibly even negative number, or maybe use a bit mask. And so these type of global properties, they tend to be very simple to specify and very convenient to maintain. And then the other type of idea that you always want to think about is, what is the worst case scenario? And that's what should lead you, especially as you start writing more stuff, you will want to ask yourself, what should never happen? What will be the case that will basically break the entire thing? An example here will be that the set number stops working. The example will be that set number only allows you to set specific values. The example will be that the increment stops working and doesn't work. An example that we had for eBTC was we had a TWAP, and so our worst case scenario was that the TWAP will overflow. And so the TWAP was allowed to do anything, but it was not allowed to overflow given a specific time. And so our check, which again was fairly simple to write, but would have been something like not has overflown, and then time is less than, our end time, because obviously everything overflows at infinity, but it wouldn't overflow within 100 times, 100 years or something like that. So hopefully that gives you a couple of ideas for how you want to look at getting started with fuzzing. And then I'm going to show you where I got the this idea for how to skip compilation, which was a question I got this week. And basically it's here, and you wouldn't necessarily do it, but fundamentally that's all you have to add. You will go to your critic args and you will add -- ignore compile. And if you do that, then Medusa and Echidna will skip the compilation phase. So if I go on medusa.json and I add this, then Medusa should be noticeably faster. because it's gonna try and skip the compilation. And you can see that it's faster. What is unclear to me is though if Medusa would use the out folder from Foundry, or if it's gonna use the combined sol C, which means that if you make changes, they're not gonna be built. So I guess we can try that together here. Maybe I'm gonna go here, I'm gonna do a function, new check public, and basically assert false, new check. So obviously this will not work now because we're skipping the compilation. So obviously this is not gonna work. We don't expect this to be there. So we're searching for it and we don't get it. That's fine, that's completely fine. But now let's try and build with Foundry, which is what I said in the beginning. You will always iterate with Foundry first. And so let's see, we have some identifier already declared, whatever, tuple. Let's see if I made another mistake or we're fine. We should be fine. And so now we compiled with Foundry. So now let's run with Medusa and see if it's gonna use the Foundry output, or if you're basically screwed and it's actually not gonna work. So it seems like it's the latter because Medusa uses the critic export. And so what that means is that you can do the skip, but it's gonna come at the cost of the fact that it literally is not checking your new stuff. And I think that's not ideal. That's probably ideal only for cloud deployments. There should be another flag that I don't remember to check fresh or something like that. That could help you. But fundamentally, my answer to the question of being faster is instead to focus on the Foundry aspect for as long as you need, and then only once you've explored all of the Foundry aspect, move towards the fuzzer. Because of the fact that you have that parallel, there is literally no reason to push your run to the cloud if it's not gonna compile. So you will always run it locally, and then you will verify that it works, and then you verify that Medusa works, and then you push it to the cloud. So that way your workflow is leveraging these bigger timeframes, because obviously when you push to the cloud it takes longer, but you also run it for longer. And so you're being smart with your time by doing the minimal effort necessary to get you to the next step. So that's the presentation. We also had another question by Renzo. Let's see. If you guys have any other quick question, drop it in the chat. So I guess this was the Renzo question. Then the next thing I wanted to show quickly was this token 21 issue. And so if you look here, you can see that there's no, no, this is get ignored. There's no Open Zeppelin here. So by definition, it's impossible to compile this project. So if I literally do this, just grab the Foundry code, and then I go on counter and replace it, and I call this test token, and then I delete all the tests. I deleted the wrong one. So this is going to be called test token, and then I delete the test folder. You will see that there's no what's it called? There's no Open Zeppelin, so there's nothing I can do. So all you gotta do is forge install, and then you go on Open Zeppelin contracts. So it's gonna look a little something like this, where you will forge install Open Zeppelin dash Open Zeppelin contracts, and then because we have a commit, I will type no commit, and basically it's gonna install it. And then for the remappings, you would have to set them up so they will look a little something like this, where at Open Zeppelin will be equal to lib slash Open Zeppelin dash contracts, and that should basically be it. I don't know if Open Zeppelin contract has a contract folder. Maybe it doesn't. No, maybe it probably does. So because it does, then this with a slash here will map out to the correct remapping, and so this will work. And when you push it to the cloud on Recon, Recon is also going to be able to build it. Another common issue we found that happens all the time is people type something like this with the incorrect casing, and if you're on a Mac, the incorrect casing actually works fine, and so you're not going to detect it locally, but once you push it to the cloud, because we use Linux, it's actually going to break. And so that's something to keep in mind, is make sure all of the paths are correct, and once they are, it should be fine. And I'm going to see if I can get the broken one. As you can see, I changed this to a lowercase and it still works, but if I were to push this in the cloud, it would still be broken, because Bash is, or Linux is case sensitive. So hopefully that helps you get started, and then obviously you can use the builder. And that's kind of the last thing I will mention, is all of the demo was done on the local side. That's because you will most likely set yourself up with the local side first, then that way you know everything works and Medusa works, and then you would add the repo and build it, so you can then add your target functions later. That's because that way you already know the project compiles and it works, and so the target functions, they tend to be a bit of a a copy paste stuff, and so it makes a lot of sense to set this up after. That way you only grab the functions you need and you already know what you need, and it can be more convenient. So that's it for today. Do you guys have any quick questions for me? About skipping compilation, what happens if the existing build is deleted before running? I bet it simply fails. So I'm gonna delete the critic export. I'm gonna go medusa.json, bring back the ignore, and I bet it will simply fail, say that there's no, there you go, blah blah blah, unknown file or something like that. So it basically fails, and it's
So how is it built in the first place?
how is it built? It just reruns Foundry, and then it creates its own custom format.
Yeah, so that's what I'm thinking about. So what if you delete the current build, then you rerun Foundry to get a build again, and then you skip this time? Does it work?
No, it's not gonna work now, because I mean now Medusa, there's no tester anymore, so maybe it's gonna fail. But if you have the flag and you delete the critic exports, then it's not even gonna try to compile, and so nothing will happen. While if you remove this flag, then it will try to rebuild. I think what you could do to build it locally would be to use, what is it, critic compile. So I don't remember if I have it here. But basically you could rebuild by using critic compile. I think maybe even critic compile dot would allow it to basically try using Foundry. And you can see what it's actually doing is it's running forge build with skip test, blah blah blah. And so if you want to match the configuration, you will basically do dot dash dash foundry dash compile all, and that will also force it to build the rest of the stuff. And so if you want to have a more advanced workflow, you will probably have some sort of a a build.sh file where you will most likely run your critic compile here, and then you would perhaps run Medusa. And so that way you could also have this setting where you never rebuild, because anytime you want to run, you just run Medusa, and then anytime you want to run and build, you run build. And so that's the more advanced workflow. And I think the reason why it was done by Curves was to just save on compilation time and memory, because the Foundry is actually can take a lot of memory just to compile your project. So sometimes it's more convenient to just commit the build to your source control. But fundamentally, my answer to all of this is instead to basically get good and use Foundry better. Don't use Medusa better, because the Medusa times will always be slower, no matter what you do. Even if you optimize Medusa, another idea to optimize will be to have the SRC, the tester in the SRC instead of the test folder. But basically, you will always be slower by the fact that you're using a tool that is meant to be used differently. And so the biggest advice I can give you is stay in Foundry until you're confident and then move to Medusa. And you're not gonna have this type of considerations again, because anytime you need to get to meaningful coverage, you'll know it takes a few hours and you let Medusa cook. And anytime you need a quick answer, you'll just go to Foundry and explore that directly.
So in my case, why I was considering this compilation skip was because I was running into this Medusa error of max code size exceeded. So I was wondering if there's a way to skip this compilation and just have the compilation built by some other compiler and test that compiled contract.
No, but that's not a real issue. You can just specify the maximum compilation size. Check. So on Medusa, it literally doesn't check for the code size. So it should compile and run fine. And then on Echidna, I don't remember the command, but if you Google Echidna code size checks, it's here, bypass 170 from Liquity, was an old Liquity fork. You would actually just pass this code size parameter on echidna.yaml and you just increase it to whatever. And now you can deploy contracts that are bigger. So those are not good reasons to do that. The only reason you will skip the build is if you're doing via IR. But then again, even in those cases, you probably are not like it's you are better off solving it at a different level. That's really the biggest thing. Simply because like every time it saves you 5 seconds, there's gonna be the time where you do a change or your colleague does a change and it doesn't rebuild, and now you waste an hour debugging an issue that doesn't exist. So I would generally instead focus on the Echidna side, on the Foundry side, because that's gonna be consistent and it will always work, and it's gonna be a lot faster consistently.
Thank you.
Awesome. So that's it from me, guys. Thank you for attending our office hours. Have an amazing rest of your week, and I'll see you next Thursday. Have an awesome one.